Here's part of the coast at, I think, Dash Point, might be Brown's Point. Give me a very low number. Brown Point, give me a very low number because it's in the foreground for how far down the image needs to extend beyond centre. And way to the right, give me an idea of how far right I need to extend it to fit all of these points in. And here's how where I started. We've got labels, you can see, well, I hope you can see, Point Robinson on the left, Dash on the right, and wow, 33% zoom. Let's get a 200% zoom. Point Robinson on the left, there is the coast of Point Robinson. Now that is not an outline, that is a set of 4 lines. The top line is the flat prediction, the lower lines are the geometric and 3 refracted predictions. Those black dots are the ends of runways 16 right, 16 left, 34 left and 34 right. The 2 eye shapes are the flat and combined various curved predicted positions of the tower. You have dots for the summit of Liberty Mountain, just to the left of the tower. Blue lines for the sea surface, green lines for the coast in front of SeaTac. And at this point you can already see a difference. If I zoom back out, wow, that zoomed slowly. The shape of Dash Point and Brown Point, see Brown Point drawn in black and Dash Point kind of clash here. But the shape of Dash Point and Brown Point, the shape of Dash Point, the shape of Brown Point, the shape of Point Robinson doesn't change much. The apparent shape of the sea surface doesn't change much. The apparent height of SeaTac Tower doesn't change much. But there are things that change. The flat prediction at the top has Dash Point high above Brown Point, where the curved predictions at the bottom all have Dash Point behind Brown Point. And the flat prediction at the top has Liberty Mountain high above SeaTac Tower, whereas the curved predictions below it have Liberty Mountain summit pretty much level with the top of SeaTac Tower in the view. Also in the middle, it's close, but it's there. This is something that FE Peer Review pointed out in a very recent video. I took too long to make this one, I'm sorry. The coast in front of SeaTac is above the sea at 1.86 kilometres. It's farther away, so of course it's going to be higher in your field of view on a flat above a flat surface. So of course the flat prediction has the coast farther away, higher up and nearer to the eye line across the middle that isn't included in this image. Eye level across the middle, not shown. With curvature, the coast at SeaTac is out of sight down behind the water at 8.16 kilometres. So I got this far. I did get this far. And again, I have to go to zoom to fit so that I can go to the next image. Bobby Shaft uploaded another video, which included this. It included the state of the tide, notably below mean there. It's above the 0, but it's below the average. So, is that high or low relative to what I was predicting before? More to the point, it includes the camera position right there in the center. The camera was here. And there is an insert on the right showing that 2 cameras were there in that curved corner of that structure. Right? So all that clutter to the right. Oh, this is looking the other way, obviously. Ghost log, I have no idea. That brown thing, I have no idea. But what you're looking at there is the structure, the walkway sticking out, where I thought the corner nearest the target was the obvious place to be, which would be the bottom corner of that structure. Again with the zoom. there would be the obvious place to be. Is that the front end of an aircraft or what? But while I was working, Bobby was preparing another video which revealed the camera had actually been there. Now that's a tiny change. It's the kind of thing only a perfectionist would really care about. But he also included that the camera was, well, it says there, elevation 17 feet, but that he measured the camera to be 22 feet above water level. 17 feet, about 5 meters. I put in 4 meters, 22 feet, it's more like 7 meters. So yeah, I was this wrong, 6.9 meters out in terms of... Oh crap. I've just realised. I am sitting here recording this and I've only just realised that was... See in the top left, in the very top left of this image. Right up here. Nope. Oh look, there are actually jump arrows I could use. He was in the very top left of the image. I've got him over on the right, and I've made this 6.9 meter jump to the side and corrected the altitude. I didn't move him to the right place anyway. He was farther west than I thought. He was farther west than I corrected myself west. That explains why you can't see the windows in the floor. Those windows in the ground are kind of odd. I thought he was just to the left of them. No, he's way up there. Left of that, north of that aircraft nose or whatever that thing is. Okay, while recording this just now, I have found out that I've got the location wrong, and I'm not about to correct that. Deal with it. How far that is? Probably not very. What's that? 7 meters. What's that? 1, 2, nearly 30 meters. Not very far. I'll bear that in mind while I record the rest of this. Okay, I redid it. I got this. This is, you probably can't see much yet. If I zoom in to 100%, you can only see a small part of it. But we have the Point Robinson coast. I've made this twice as large, and I've drawn it in darken only, so where lines overlap, you should be able to see both of them. Point Robinson coast is the green from the left, coming in as far as the green from the left extends, and then going back across itself. And it appears as pretty much a flat line across the image. Flat, curved without refraction, or curved with refraction. Over on the right, the same shade of green is Dash Point Coast. And as before, the top line is flat. And come across to the left slightly, Brown Point is in paler green. And the flat prediction for Brown Point is below the flat prediction for Dash Point. So you would be able to see Dash Point coastline sticking out into the water beyond Brown Point if it was flat, according to these calculations. Down below you have geometric 1.1R and 1.25R refracted curved Dash Point sticking out pretty much behind Brown Point. And this dark blue from way over on the right here to way over on the left here is the water at 8.16 kilometers. Again, the top one is flat, and at the bottom you have geometric above 1.1R, above 1.25R. That's the foreground. This bluish green colour across the middle is the coast in front of SeaTac, and just as before, with the flat calculations, it's above the water, and with the curved calculations, it's out of sight behind the water. Then there's grey. 1-6 right, 1-6 centre, 1-6 left, 3-4 left, 3-4 centre, 3-4 right at the ends of the runways, and tower is the tower. And as before, the entire flat prediction of tower is above the entire curved prediction of tower.